Okay, so do you see my screen?
Yes, code.
Cool. Yeah, well, that will be mostly code because, well, Solidity. Yeah, so what I wanted to do for quite some time now is basically go over all of the Solidity documentation once again. I did a number of times before, but it changes regularly. And so, yeah, I just decided to went all over it and collect the stuff that somehow that I somehow missed during the years of doing smart contracts, and also to notice stuff that I didn't see being used much, even though I think they are pretty usable. Yeah, and so I redid all the examples, have all the code here. And so the idea is I'll be telling each point, and then if anyone will have any questions about the particular topic after I describe all the after I present all the topics, in the end you can just tell, okay, I have a questions about that one, I can scroll back to it, we can run it in Remix and have some details on it. Okay, so first of all, something that I haven't seen been used by anyone yet, and well, it's not yet fully supported in the language, but you can define errors in Solidity, and that is pretty helpful when you want to report meaningful error messages like during the reverts. So as you know, right now the community standard is like to do something like revert, or it's usually require condition and then like swap k, something like this. Well, without much details, like it gives you the idea of where is the problem, but then you need to go and figure it out. Well, now you can do something like revert, and you specify which error you want to revert. You can pass the arguments in there. It will all be maybe encoded, and then the one who sees the error can pretty much get more idea of what's going on. Yeah, this is the first thing. Second one, yeah, so since Solidity version 8, you know that or you don't know, so the safe mass, like safe underflow and overflow checks are enforced now by default. This seemed to be a cool thing, and mostly will just make all the code even easier to read, because almost everyone just uses safe math without thinking, just to be on the safe side of things. Even though there is one pitfall that I think some people might fall into. So if you notice this particular function, you could see that what I'm doing here is I'm subtracting 2 from 1, then I'm adding 3. So in before, like in older versions of Solidity, this would be all right, because in the end, you would just get a result of 2 and everything will work. You won't even notice that there is a problem. Right now, in the 8th version, only this one will work, because after every operation, it checks for the underflow and overflow. So I think that at least some number of the contracts of before version 8 the ones who didn't use the safe mass could have points in their code where they went underflow or overflow as part of the expression, but in the end the result of the operation was all right. And so now it will start to fail probably at runtime when they will launch their contract. So should be careful with it. The people who will go from the safe mass to the new syntax of always checked, always using safety checks won't have any problems. Yeah, but still you can use the unchecked blocks, which allow you to disable, to tell compiler to disable the safety checks, and it will all work as before. And it is a bit cheaper if you're sure what you're doing. This is cheaper than doing the extra checks every time. Okay, now funny thing, when you push to state arrays, you get, I think previously, as far as I remember, the push just returned the length of the new length of the array. Now the push returns the reference to the element that is being pushed into the array. So for instance, you can do something like push, and then to whatever is returned, you just assign the new element. Pretty much the same as you did before by pushing the element right into the array, but yeah, just allows some new syntax. The funny thing though is like the old syntax and this kind of new syntax uses like equal amounts of gas if you use the optimizer, but if you save the reference into a local variable first, and then you fill in this element in your array after the fact, it will be cheaper. For whatever reason, I don't know why, optimizer is having easy time optimizing like this this storage accesses better than these ones, for instance. Yeah, so this was the case before too. So yeah, in general, if you want to make things cheaper, just write your structs in this particular way. Now there is a new thing which is which allows you to concat arbitrary number of bytes variables, fixed and dynamic size ones. So basically, you have a member concat on the bytes symbol, and yeah, it works pretty much the same as IBM code packet, but only allows you to supply it with bytes parameters. So you basically you supply it with something like this, and in the end you get just long byte array. Now, yeah, one other thing that I totally didn't know before, I don't know when it appeared, and it could be useful, I guess, in some cases. So you could also do push and pop on just on byte arrays themselves. So basically, you can push a single byte on top of the byte array. You can pop from it. Only works on the state variables. Well, because in memory we don't have we don't really have dynamically dynamic byte arrays. Okay, yeah, so a number of cool things that you could derive from the type function, which gets the information about type of what's passed into it. So I don't know how this could be used yet, but perhaps it could be in some way. So you could get the name of the contract that you're passing into, but it's pretty much the same as just using the name itself if you already have it at compile time. Now, previously, you could usually only get, I don't even think you could get creation code or runtime code from inside of the compiler, like from inside the contracts, but now it allows you to get deployment code and the code that's going to be deployed after the constructor is run. And yeah, one interesting thing is that it's common standard to use the EIP165 interface IDs inside your contract and to define them. Now you don't really need to like have those constants inside. You could use the type on the interface, and it will have a member, the interface ID, which will produce the same signature as you would probably put in the contract yourself. Yeah, Create2 is on the block for quite some time now, but still I see that mostly people use it as through some open sapling libraries and through assembly. While Solidity also allows you to just supply the salt during the contract creation, and it will have the same effect, just much easier to read. So consider using that next time you need to create too. Now, funny thing about cheap events, I've never seen anyone use anonymous events before. And that's a pity, I think, because they make your events cheaper, and really like indexed parameters are cool, but they are more expensive and they are not mandatory for any functionality that you want to have. So yeah, they make the UX easier, especially maybe for light clients, but I think ultimately whatever can be done off-chain should be done off-chain. So you shouldn't really be using indexed arguments in your events, and probably you could even scrape the name of the event itself and just use anonymous events. Well, in this particular case, it will save you 400 gas on every event emittance. So yeah, consider using anonymous events. I've never seen anyone using them before. Yeah, one inconvenience which might be surprising to somebody, that bools in state take 8 bits instead of 1 bit. So when you're trying to save on storage as hard as you can, you try to pack your variables real hard, and you might think that you could put 8 booleans in a single byte. Well, you can't. Every boolean will take the whole byte, so you can have only 32 of them in a single storage slot. And I hope that eventually Solidity developers, like I mean the ones who develop the language itself, will introduce a type that will take 1 bit instead of 1 byte, and that will make usage of bitmaps easier for everyone. Now, yeah, a few other things. You could declare functions, enums, and structs outside of contracts so that they are globally available and does not pollute your contract code. So you could, I don't know, put some utility functions outside of your contracts. You could declare structs outside of them so that multiple contracts could use the same structs. So could be useful. Now, yeah, I didn't notice, I noticed that people use short circuits a lot in other languages, but somehow not in Solidity, while Solidity supports the same short circuit logic as plenty of other languages. So in this particular example, Solidity will not execute the fail function if the first function returns true. So, well, the logic is just the same as in many other languages. It's just probably you could use it too. Sometimes could be useful, and especially when you're having some conditions, like you have an if and you have plenty of conditions inside of it, you could always make use of this to make the condition verification cheaper, so that when the first part of the condition is true, you can be certain that the other ones won't be even checked and won't spend your gas. Now, yeah, another thing about the types, you could get members which are called max or min to get the smallest and biggest possible value for the type. So, yeah, for instance, previously people could have used something like unit -1 to get the biggest unit, but right now it's not allowed because of the underflow safety checks, because this is effectively an underflow. So you need to use the type max. There is one strange, well, not strange, but probably unexpected thing, that when you're using integers, well, people don't use integers in Solidity a lot, but some people do. And if you have the smallest possible integer, if you'll try to negate it, the overflow check will fail the transaction at runtime. It will compile and everything will be cool, but at runtime, this will revert, because the smallest, like we have a 0, and so on the negative side of of the type, you have more space than on the positive side. So if you take the smallest number, negate it, you get over the highest possible number. So don't do this. Okay. Finally, some people don't know of such a cool function that is available in ABI namespace, which is called a function called Gcode, which basically allows you to decode ABI encoded data easily without going into assembly and managing the memory yourself. So yeah, this one's pretty useful and flexible when you have raw byte arrays, and you don't even have to specify exact like you don't have to specify the types for the whole byte array. Like if the byte array will be, for instance, much longer than the types you specify, then the Solidity will just take start from the beginning of the byte array and cut the slices of what you wanted. Like I specified that I need 2 uints, so it will take first 64 bytes, and that will be 2 uints I need, and no matter whatever else is there in the end. So this is usually very useful. And the same, the close thing that people also don't know often is that we have slices in Solidity. They only work on call data, but you could easily split your input byte arrays into whatever chunks you like by using Python-like syntax. Now, yeah, some things about readability improvements that you could use. So since recently underscores were introduced to split the numbers, and that might make things more readable, but it also might make them not so readable. So use sparingly and make sure that you only use them where needed. Now, the cool thing, which I haven't seen in any other language, I think, before, is that strings can be concatenated without any concatenation operators. So basically, you just write your strings, and there won't be any new lines or stuff. You just keep writing, and you keep stuff in your like column bounds, and they will be concatenated. You can do even like in a single line, but that probably doesn't make much sense. But yeah, using it to spread long strings over multiple lines, really cool, I think. Now the same thing works with Unicode. You just need to use the Unicode prefix, and then you can use all the funny emojis and stuff. And the same works for hexes. If you have some pretty long hex, absolutely no need to have a super huge line in your function. Just split it in pieces of 64 characters. It will make it much more readable. Now, as recently there was immutable variables introduced, which are super cool because you have to use them, you must use them, they make your contracts much cheaper to execute. So it's basically a constant that you can define at construction time. There is one pitfall that people sometimes have a hard time to overcome, is that, for instance, imagine a ERC20 contract, and you're having some checks in the before token transfer function, which are checking some immutable variables. Well, it will fail. Like this particular contract won't compile if I do this, because in the constructor, I define this immutable variable, and then in the mint function, I'm trying to read it. And well, basically, I cannot read immutable variable from the code because during the construction, there is no code in the contract. So cannot use this, this won't compile. Well, to overcome this thing, well, basically you just shouldn't rely on immutable variables in your constructor, and instead you could split your construction process in a couple of functions, then use a deployer, helper deployer contract that will do the deployment, then we'll call your minting function, for instance, which will check the immutable variable. But yeah, but always use immutable variable wherever you can. Yeah, now another thing that is, I haven't seen a single time being used, I think, except of in my own contracts once, sounds like a long time ago. But yeah, you could, we have in Solidity since some time, we have function types, basically. So you could define like functions as arguments in your other functions, or like in state variables and things. And they could even be external. So you could pass a function from one contract to another contract for that contract to execute it, and that could result in, for example, in a callback or things. And it could really add some nice syntactic sugar to your code. So, for instance, in this particular example, so we would call it function in the caller. We will pass the address of this contract, and so what we see here is that we're going to call the call me back function, and this is a function callback. So I'm just basically passing the function, well, the reference to the function callback, and it will contain the address of my contract and the signature of the function. So I will pass it here, and well, call me back function already expects something like this to be passed in, and it can now execute it, which, because of this is the external function, it will result in my contract being called back, some actions happening, and so on. Yeah, so not only the external functions could be passed around, you could have like some pure functions or view functions that, for instance, I don't know, you have some function that checks some condition, and you have plenty options of what you want to check, but you are always checking it as part of another function, so you could just pass it in. Well, basically, yeah, you could pass functions as parameters in Solidity, and this is really cool. This is used commonly in many other languages. And yeah, I wanted to finish my presentation with a bit of design considerations post Berlin hard fork. So as you all know, one of the major things of the Berlin hard fork was the increase of the gas costs of reading storage, writing into storage, especially the cold storages, and calling contracts that haven't been called in the context of this transaction yet. So well, with the storage, everything is, well, basically the same as before. Storage was always expensive, and we always thrive to use it very optimally, to do as little writes as possible, to store as little information as possible, and to read as rarely as possible. But with contract calls, they weren't really expensive before. And so it was common to, for instance, split your big contracts into like modules, or it was a good idea to use, for instance, like so-called clones or proxy contracts. Well, I don't think the proxy contracts are a good idea anymore, because with every call that your contract makes during the transaction, you're spending at least 2,400 more gas. And so the more contracts your contract calls, the more of those 2,400s you add to the transaction. And that's just, it just loses all the point of using proxy contracts or of using modular architecture very quickly. You'll just waste gas for everyone. So I think at this point, unfortunately, we need to start like getting monolithic approach to contracts building again. And which is even more depressing is that we cannot have multiple instances, like cheap deployments of multiple instances of the contracts. So for instance, Uniswap already like deploys every payer as a full contract, because, well, probably they figure out that payer is something that's going to be used often, and so it should not have an overhead of additional calls. But right now, those additional calls are getting so expensive that even if your contract is not used very often, probably in the lifetime of your contract, it will still be cheaper to have the full code version instead of a proxied version. So yeah, that's pretty much what I wanted to say. And if anyone have any questions about any of those points, I can scroll back and we can look at it closer.
Yeah, I have a question.
Sure.
Do you hear me well?
Yep.
Yeah. So why did they decide to incentivize to go to more a monolithic contract approach instead of building blocks like before? Is it because it seems like a strange choice? It seemed to be a step backward from the feeling I get from you.
Well, the thing is that wasn't the purpose of the change. The purpose of the change was to protect the network from denial of service attacks and basically to properly price the resources that our node operators use in order to basically run nodes. Because like, yeah, calling the contracts is a really expensive operation usually, because the contract contract code will probably not be sitting in your memory. It will be stored somewhere on the disk, even if it's SSD disk. And so calling some random contracts in context of a transaction is an expensive thing. I think in the future we could overcome this by introducing accounts which like proxy accounts on the EVM level. So if we will have some accounts that will be like aliases to other accounts and will not impose any gas costs on like this proxied logic, basically, when you have like 100 of contracts that use the same code. So right now, all those 100 of contracts will be paying overhead every time they're executed. But if we have a native proxy account in the Ethereum, then we could make it free to use aliased contracts and or like make it super cheap, because they could be made optimal on the node implementation. And so, yeah, I think in the future we will overcome this problem. But for now, just just try to use as little contract calls as possible, unfortunately.
Thank you.
I have a noob question.
Sure.
How is gas calculated? Like when you're hovering over stuff, that it shows like a gas value on some of the operations.
Like this ones?
Like in the bottom of the editor, I had like a gas cost. So I'm coming from like a from like the Python world, where like I don't ever think about the execution underneath. Like it's just, that's technically free for me. So is it like per write or read, or is there some other?
Yeah, well, so there is the whole table of basically any operation that the Ethereum virtual machine performs, it has a cost or a price in a unit of gas, which is called gas. And so like storage operations, when you're writing to the, well, basically to the disk, is the most expensive one. And it's like 20,000 gas. And for instance, like putting a variable on the stack will be like 2 gas. So you could, you know, they are trying to be priced properly. Like, I mean, so that the cheap operations are actually cheap, and that the expensive ones should be discouraged because they are expensive. And so this creates incentive for the contract developers to basically write effective and optimal code.
Interesting. I like how there's the incentive. You're like, no developer, don't write that code. You need to do it this way, otherwise it's going to cost a boatload of money.
Yes, yes.
Sweet. And I think, Antoine, are you still here? Or did you have a question?
Yeah, it's just wondering, you mentioned that anonymous events were cheaper, and well, I don't understand why.
Yeah, okay, that I can easily explain. Yeah, so you see the pricing for the events are calculated like that. So you have 375 per indexed per topic, basically.
Yeah.
Per topic, and then you have plus I think another 375 per 32 bytes of data, something like this.
Okay.
And so when you don't have an anonymous event, like in this particular case, if the event is not anonymous, so what you get here is one topic plus 64 bytes of data, right? But if the event is anonymous, then you have 0 topics plus 64 bytes of data. So you basically, like, there is no topics at all. So in this case, it will be just like yeah, like this, and in this case, it will be like this, close to this. Like there is, of course, like Solidity does some. There is some additional things. In the event itself, also costs 375
right.
in both cases, and that's why it gets up to these numbers. Yeah.
Okay, that's cool. I have no idea. How do you, if you make it anonymous, can you still fetch it? Can you still watch it?
Yeah, absolutely. You could watch all the events. Well, you won't be able to like distinguish them by topics, and you won't be able to filter them, but you could still do something something like say if you emit an event with a struct and like some lightly packet struct, and you could just identify the event, well, either by the context, like you know that your particular contract have events that either emit 2 parameters like 64 bytes or 96 bytes. Yeah, and then you could pretty much know which one you're looking at just by looking at the length of the data in the emitted event. Also, you could, well, basically you could add an identifier in the data field, and the data field is a bit cheaper than the topics field, and it would still allow you to identify the event properly, and it would still be a bit cheaper.
Oh, that's crazy. Okay, thanks. That's really nice hack.
Awesome, Oleksii. Thank you for again for the talk. I think anytime we can dig into the code, everyone appreciates it extra much. So appreciate it. Fun to learn about Solidity, coming from a non-programming developing background for me personally. So yeah.